We all are space travelers. We travel through space and time at the same time. Let me give you an example. A trip to the grocery store. So, if the grocery store is located 500 meters away from your house, and say about you take about 5 minutes to reach that place, you just moved through space and time. Now, as I've given you a really small brief about space and time, let me ask you a question. Can we travel through time like in science fiction movies? The answer would come to you at the end of this video, but Einstein, as always, had something to say. He gave us a few insights into this topic. His first insight was that all of us are just bodies floating in space with nothing. The whole notion of space and time is completely lost. He says that we need to measure events. He said this because an event is succeeded by the next. His second insight was that the standard of measurement should be the speed of light, which is a massive 186,000 miles a second. The light's value is an invariable, but he meant that a person running at the same speed would be measured with the same value. Two scientists tried to measure the speed of Earth by measuring a speed of a beam of light moving through space. They did this again and again, but they came up with the same value of 186,000 miles a second. By this, we can conclude that time is relative. Relativity is a wide ranging theory developed by Einstein. General relativity revolves around gravity. Gravity defines macroscopic behavior. So, generally, relativity describes large scale physical phenomena such as planetary dynamics, birth and death of stars, black hole, and the evolution of universe. It also focuses on light bending due to gravity. Yes, gravity can bend light. This is known as gravitational lensing. Light travels through space and time. Light traveling through space and time can bend or warp or curve due to gravity. Basically, light will dip and curve in the presence of massive celestial bodies, which have a huge gravitational pull. Now, let's attack the question. Can we travel through time? Imagine a device called an Einstein clock with two mirrors, 186,000 miles apart, and a ray of light between them. We give this clock to two people and sync their time. Now, let's take them to the field and place them one on top of each other. Let's ask the first person to move. If the person moves for 2 seconds, then 6 seconds would have passed for the second person. If light has a constant speed, time is relative, and you can see why. So, if one person or the first person goes for a 4 year trip, then 12 years would have passed for the second person. So, you can say that the person two would be older. But this is from the perspective of person two. What if it was the perspective of person one? Then he will see that person two has gone and come back for 4 years. It all depends on perspective. Person one would have seen that person two has gone and come back and has grown younger. This is called twin paradox, and this proves time travel is possible. I would like to end with a quote. When forced to summarize relativity in one sentence, time, space, and gravity have no separate existence from matter. A quote by Albert Einstein. Thank you. I'll see you soon in my next video. Bye.